Okay, let's start off by defining a sequence. A sequence is an ordered list of numbers. And we call each number in a sequence a term. So a sequence is an ordered list of numbers, and a term is each number in a sequence. We designate each term with a sub n, with n being a number's term or a term's position in the sequence. So I'll show you what this means. So if we have a sequence, for example, 5, 10, 15, 20, 5 is the first term. Because it's the first term, we would call this a sub 1, because it's the first position in the sequence. If we looked at 20, for example, this is the fourth term in our sequence. So we would designate this one a sub 4. That just means that it's the fourth term in the sequence. So it's just sort of the way that we name the terms in the sequence. All right. So then getting down to specifics, in an arithmetic sequence, specifically, the difference between each pair of consecutive terms, consecutive. The difference between each pair of consecutive terms is the same. So in order for a sequence to be considered arithmetic, you have to have the consecutive terms going up or down by the same value. Okay, so if we use that example from above, 5, 10, 15, 20, you notice that each consecutive term is going up by 5. So this is an arithmetic sequence because we have this, what is called a common difference. And that's our next definition. The common difference is the difference between terms. In the example, the common difference is plus 5 because it's increasing by 5. If it were decreasing by 5, the common difference would be minus 5. So you do have to indicate sort of the sign, whether you're adding or subtracting as part of that common difference. Once we know the common difference, then we can find out missing terms or terms that follow in the sequence. So if we know we're always going up by 5, we know that we would add 5 to every term in order to find a missing term or find the next 3 terms, etc. For example, example 1 says, write the next 3 terms. And they give us this arithmetic sequence: -7, -14, -21, -28. And then they put this little ellipsis, which is the 3 dots, meaning that there's information left out. We need to fill it in. So we can see in our terms that we have a common difference. Every term is going down by 7. So we're subtracting 7 from every term. Or we're adding a -7, so you could say that either way. Now we are asked to find the next 3 terms, meaning we need to add a -7 or subtract 7 to -28, which would be -35. If we subtract 7, we'd get -42. And one more time, -49. So those are the next 3 terms in my sequence. If they ask you to find the common difference, in the sequence, we would say that the common difference was -7, because that's what is separating each term, one from the next, is -7. What questions do you have so far? All right, moving on. We can also graph arithmetic sequences. And we graph arithmetic sequences by plotting the position of each term as an x value and each term as a y value. And then we can plot them as coordinates on a graph. For example, if they tell you to graph the arithmetic sequence for 8, 12, 16, what we want to do is take these values and make them into a little function table where according to our instructions, we plot the position of each term. Oops, I left a word out. Position of each term as an x value, and the term itself as a y value. So our first term, we'll put 1 for x because it's our first term, and our first term itself is 4. So we're going to plot that as our y value. Our second term, we're going to call that 2 for our x, and our y, our second term is 8. So we'll put that in our y column. Our third term, 3, pairs with 12, and the fourth term we've been given will be 4, and the y value is 16. Okay, so to graph these, I'm going to do 1, 2, 3, 4, and I'm going to go I'll just go by 4s. 4, 8, 12, 16. So then I can plot each of these. 1, 4, 2, 8, 3, 12, and 4, 16. I do not connect the points when I graph an arithmetic sequence. I simply plot each coordinate as a point, but I do not connect them into a line. Okay, so that's how we graph if you're instructed to graph. Okay. Example 3 is sort of working backwards from this. So if you're given a graph, can you identify the terms in the sequence? So it'll say, does the graph represent an arithmetic sequence? They're going to give you a graph with values on it. Let's do 3, 15. Okay, and here's our points. We've got 115, 212, 3, 9, 4, 6. So this is all we're given. Oh gosh, I totally spelled that wrong. Arithmetic. We need to determine whether or not this graph represents an arithmetic sequence. So we can do this by looking, but we can also do it by setting up a little table and seeing if there is a common difference between the terms. So our x's are 1, 2, 3, and 4, right? Those are the x values that we've been given in the graph. And our y values are 15, 12, 9, 6. So remember, in the arithmetic sequence, we're looking at these y values. These represent the terms of an arithmetic sequence, if we do have one. And what we're looking for is to see if there's a common difference between these terms. Okay, going from 15 to 12, we're subtracting 3. From 12 to 9, we're subtracting 3. From 9 to 6, we're subtracting 3. So we see a common difference of -3. So, yes, the graph represents an arithmetic sequence. All right, questions about that? Just unmute yourself if you have a question. Jump in and ask. Okay, moving on then. Okay, we can write arithmetic sequences as functions. And the formula for writing an arithmetic sequence as a function is this. A sub n is equal to A sub 1. So actually, let's write the whole thing and then we'll talk about what each term means. A sub 1 plus n minus 1 times d. So then we need to talk about what each of these letters mean. Okay. A sub n basically means that like it would stand in for like your y equals, or it would mean the sequence can be represented by. Okay, so there's not really anything you plug in for this. Like this is always how you're going to write the equation of an arithmetic sequence. Like when we write a linear function, we say that y equals, mx plus b. When we write an arithmetic sequence, we say this basically means the arithmetic sequence, a sub n, can be represented by these items. A sub 1, as we talked about, will be the first term in the sequence. So this will be a number. Whatever that first term is in your sequence, you'll plug in here. Plus the quantity n, this is going to remain n. And so it just means any number term in that sequence you'd plug in here if you needed to figure out what it was. So leave this as n, and I'll show you, we'll practice a few of these so you see what I mean. Minus 1 times d represents the common difference in the sequence. And notice that the d is outside this parentheses. I wish that they would put this first. Like I think it would make more sense to put the d here, because then it becomes clear that you need to distribute that d to both terms. But you will need to distribute the d to both of the terms inside the parentheses. So let's do an example. I'm going to leave this up so that we can see it. I didn't leave myself much room. Example 4 says, write an equation for the nth, this is where this little n comes in, the nth term of the arithmetic sequence, 14, 11, 8, 5, and continuing. So we've been given this. We have to write a function using this formula that would describe this arithmetic sequence. So what do we know? We know the first term. 14 is our first term. That's going to be what we plug in for a sub 1 because it's our first term. The other thing that we need to find is the common difference. So we look at our sequence and we see that it's going down by 3. We're subtracting 3 between each term. Once we know those two pieces, we can plug in what we know and simplify. So we're going to say a sub n equals a sub 1, which is 14, plus the quantity n minus 1 times the common difference. So times negative 3. Then we need to distribute this negative 3 to both terms inside the parentheses and simplify. So we'll get a sub n equals 14. Negative 3 times n is negative 3n. Negative 3 times negative 1 is positive 3. Then I can combine my like terms, my constants here, 14 and 3, and I get that the equation that describes this function is a sub n equals negative 3n plus 17. It kind of looks like slope-intercept form, right? We have two separate variables. Whatever this n is determines what this output will be, right? This n will represent a term, the nth term. So however, if you want to find the 15th term, you would plug it in here and then solve for what that 15th term would be, which is what we're going to do next. So first, this is the equation that represents this specific arithmetic sequence. Now, the second part of this, and I got to flip my page. The second part of this, they ask us to find a sub 50. And remember this notation, a sub 50, when we found a sub 1, that was the first term. So to find a sub 50, what that means is find the 50th term. So we go back to our equation that we just found, a sub n equals negative 3n plus 17. N represents the number of the term. So if we're finding the 50th term, this at n is where we plug in 50. So we're going to say that a sub n equals negative 3 times 50 plus 17. So negative 150 plus 17. Our 50th term, a sub 50, then would equal negative 133. Let's do another one of these to practice. Okay. Let's do write an equation for the nth term. Then find a sub 25. Write an equation for the nth term, then find a sub 25. So our first one that we're going to do, we're going to use this arithmetic sequence: 4, 5, 6, 7. So we start with our formula for finding the equation of an arithmetic sequence, which is a sub n equals a sub 1 plus, I'm going to rearrange this just because I want to, d times the quantity n minus 1. In order to fill this in, we need a sub 1 and we need our common difference. All right, a sub 1 is 4. This is our first term. And our common difference is positive 1 because we're just going up by 1 each time, right? So our d is 1. Then we can plug in and get our equation. So we get a sub n equals 4 plus 1 times the quantity n minus 1. When we simplify, we get that a sub n equals 4 plus n minus 1. And one more time, simplifying, a sub n equals n plus 3. So that was part 1. We wrote the equation for the nth term. Part 2 is to find a sub 25. So that means we need to find the 25th term. So we're going to look for a sub 25. That means when n is 25. So we'll plug that in to what we've been given. A sub 25 would equal 25 plus 3. So a sub 25, our 25th term in this sequence would be 28. Okay. I'm going to have you do one more to practice in our notes, and then I'm going to let you go and let you practice on your own. So let's do this one. If you are given, let's do this one, 8, 16, 24, 32. I want you to write me an equation for the nth term of this sequence and then find a sub 25. So number 1 will be write the equation. Number 2, find a sub 25. So I'm going to give you a second to practice that in your notes. And then check your work up here when you're finished. Okay, so our equation a sub n equals 8n is what models this set of data, this sequence here. And then if we plug that in, if we find a sub 25, we plug in 25 for n, 8 times 25 is 200. Okay, there is one more example I want to do real fast before I let you go, just because it's one of the word problem ones. And I want to make sure that we understand how to work with a word problem when we have arithmetic sequences. So let's just do example 5 real quick, which is writing like a function from a real life arithmetic sequence situation. Okay, so example 5 gives us a chart that looks something like this. Okay, so it's like an auction going on. There's a bid number and a bid amount. So how much people are paying. The first bid is $60. The second bid, $65. Third bid is $70. The fourth bid is $75. And then that will continue. It says to A, write a function that represents the sequence. Okay, so we're going to use that same format that we just were using with writing an arithmetic sequence as a function and just plug in the information from this table. So a sub n equals a sub 1 plus our common difference times the quantity n minus 1. So a sub n equals a sub 1, our first bid was 60, plus the common difference. If we look up at the common difference in this table, we're adding 5 each time, right? It's going up by $5 every bid. So our common difference is 5 times the quantity n minus 1. A sub n equals 60 plus 5n minus 5. When we finally simplify this, remember that they asked us to write this as a function, which means we need to put it into function form. So instead of saying a sub n, we're going to say f of n. Because our function, our output, is a function. It's determined by whatever the n is. So we'll write this as f of n instead of a sub n when we're asked to write it as a function. And when we simplify, we get that f of n equals 5n plus 55. So that's our part A answer. Part B asks you to graph the function. So I'm going to do this over here. We'll just make a little graph here. We'll do 1, 2, 3, 4. And these are our n's. And these are our f of n's, or our x and our y. So then I'll just go by 60, 65, 70, 75. We would plot each of these points. 160, 265, 370, and 475. So remember, we just plot the points. We don't connect any line in there. Even though it does follow a linear pattern, we do not connect them with a line because they're discrete. The last part, part C, asks you to apply the function that you found to like a real life situation. It says the winning bid was $105. How many bids were there? The winning bid was $105. How many bids were there? So if we look at our function, our f of n is showing us how much each bid was worth, right? This value, f of n, is how much each bid was worth. So what we need to do is plug in 105 for f of n, and then it'll tell us how many, like what number bid $105 was. So we'd say 105 equals 5n plus 55. Subtract 55 on both sides. We get 50 equals 5n. And then divide both sides by 5. So we get that 10 equals n. There were 10 bids. Okay. All right. So I'm going to slightly adjust what I had assigned to you guys in IXL.